going through longest palindromic substring. So given a string S, return the longest palindromic substring in S. So for example 1, given input S equals to BA, BAD, the output is BAB because you can see the center character is A, and on the two sides it's B, which is equal of each other, so this is a palindrome. And you can also see ABA is also a palindrome. You can see that this is also a valid output. Let's look at example 2. Given input S equals to CBBD, the longest one is actually BB because given this substring, you can see the characters on both sides, they are actually equal. Okay, so how can we solve this question? Let's look at the example. Given B, A, B, A, D. Okay, so for this given string, what we can do is we can first set the anchor point as one of the characters, and for each of the characters we can have a left pointer and a right pointer. And for this left pointer, we can actually check we can move this pointer to the left, and we can move this pointer to the right to continuously check whether to check for the longest palindromic substring within this anchor point. So for this example, we can see that B is the longest palindromic substring because if we move the left pointer to the left, it will be out of bound of the character. So for this one, we can have the value of 1, and once we are done, we can move on to the next character, which is A. And same thing, for A, we want to have actually a left pointer and a right pointer. So now A is the anchor point, and the left pointer will move it to the left, and the right pointer will move it to the right, and then we will check, is the character at the right pointer the same as the character at the left pointer? It is the same, so we can move the left pointer once again to the left, and we can move this right pointer once again to the right. And now for the left pointer, we realize that it's already out of bounds, so we want to return the length, and the maximum length is actually 3. Okay, so at the end of the day, we need to actually keep track of the indexes of the string of the start and the ending, so that we can use a substring function to get the real substring, which is BAB. So the formula for the start index, we can see, is actually I, which is the anchor point where we are at. For example, at this example, the index of I is 1, minus the length minus 1 divided by 2. So for example, this length is the maximum length of the substring that we found given this anchor point. So given this anchor point A, the maximum longest palindromic substring is actually 3. So 1 minus 3 minus 1, so 3 minus 1 is 2. 2 divided by 2 is 1. So 1 minus 1 is actually 0, for example, right? And this is the start of the longest palindromic substring that we are interested in. And the length and the ending is actually using I, which is the anchor point, plus the length. So in this example, it's actually 1 plus the maximum length, which is 3, and the end will be 4. So if we are going to use the substring function, it will be from 0 to 4, and this will actually give us a B. Okay, so next we'll move our anchor point from A to B, and this is index 2 now, right? And we have the same thing. We have a left index and a right index. And for this, we'll try to do the same thing. We'll move the left index and we'll move the right index to find the longest substring. And we can see here we got A and A, it's equal, so the left index is now at this point and the right index is at this point. And once again we move left index to the left, we move right index to the right, and B is not the same as D, so the longest value for this anchor point B at index 2 is actually 3. So which is why this is actually also the valid output as per the examples you saw previously. Now we will move to the next anchor point, which is A. And same thing, we have the left and the right. We move right and we move left. We see that B is not equals to D, so the longest value here is 1. And then we'll move the anchor point now to 4. We have the left pointer and the right pointer, and when we move the right pointer to the right, move left pointer to the left, we can see the right pointer is out of bound, so the longest value here will be 1. So you can see that we are actually moving the anchor point for each character, and we are trying to expand from that anchor point outwards to find the length of the longest palindromic substring within that anchor point. One thing to note is this is an odd number of characters, and we also have even number of characters. So for example, B, A, B. So for even number of characters, we also need to set the anchor point and expand from the middle, but we need to actually set the left pointer and the right pointer on different characters. So let's say this is the anchor point now, right? So the left pointer will be pointing at I, but for the right pointer we need to use R plus 1, so it will be pointing at the next character beside it. So this will be the starting point given the anchor of I. Let's move on to the code now. Okay, so if S equals to null or S dot length equals to 0, we can simply return an empty string. And we also can do if S dot length equals to 1, we can just return the string directly. Now we have a start index, which is 0. We also have a max length, and we will set it to 0. So this max length is determined by setting the anchor point, then we start expanding from the middle and we get the longest max length. Okay, now we'll traverse the string, and I is the anchor point, so I equals to 0, I less than S dot length, and I plus plus. So now we need to consider the odd and even number. So here we can have a length 1, and we can do a expand from middle function, and we'll implement this function later. So we'll provide this the string and the left and right pointer. So for left we set this to I, and for right we set this to I as well. So this is for handling the odd strings, odd length string. And we also have a length 2, and we'll do expand from the middle given the input string S, and for the left pointer we set the anchor point index as I. For the right one we can set it as I plus 1. this is for handling the given length string. Okay, and now the length we can get is equals the math.max of the length 1 or the length 2. And here we can check if length is greater than the max length, then we want to calculate the start index and the end index so that we can do a substring, right? So if you remember from the formula previously, start equals to I minus the length minus 1 divided by 2, and for the end index, so we can actually use max length equals to length. So this will be these two parameters will be used later for the substring values, and ultimately we can return s.substring start and start plus the max length. Okay, now we need to implement the expand from the middle function. So private in expand from the middle, and this will take in a string s, left pointer and a right pointer. For here, we can do a while loop while length is greater than or equals to 0 and r is less than s.length. And we also want to check that the character pointing at the left pointer and the character which is pointed at by the right pointer is the same, so we can do s.char at length, sorry, L is equals to s.char at right. If they are the same, we can continue expansion, so we can do L minus minus and R plus plus. And here we will just want to return the maximum length, so we can do R minus L minus 1. So this will be the maximum length of the palindrome substring that we found by expanding from the middle of the anchor point. Okay, and let's try to run this. So we can submit. Yes, so that's the solution.